This is the homework helper for Workbook 1.3 Properties of Numbers. We'll start with question 1, and you're going to approach 2, 3, and 4 in the same way. It's asking us to use properties to determine whether the expressions are equivalent. So they want to know if this and this represent the same thing. And we can use any of the properties that we've looked at over time and in this section to help us figure out if that's true. So remember, we'd be talking about the commutative, the associative, the identity, the inverse, the distributive properties really here is what we'd be looking at. Well, in this case, notice that all they've done from this one to this one is they've shifted the parentheses. Here the parentheses are in the front, here the parentheses are in the rear. Remember, that's called the associative property. The associative property, that's really what it says, is that I can move parentheses around and it doesn't change my answer. Let's think about this just in terms of numbers for a minute, and then I'll come back to answering the question. If I said 2 plus 3 plus 4, and 2 plus 3 plus 4, but in one, I put the parentheses in the front and the other the parentheses in the rear, would I have the same thing? Well, order of operations tells me I do the parentheses first, so 2 plus 3, which is 5, plus the 4, which is 9. But if I go the other way with this one, I do 4 plus 3 first, because that's in the parentheses 7, plus the 2, which is, lo and behold, 9. So it doesn't really matter in terms of addition which one I did first. In the end, the answer was the same. And that's exactly what you're going to see here in question number 1. We can't physically add them together because they're not like terms. The 2D and the 3M that you see here in this one, they're here obviously, but they're not grouped together. I can't actually make anything out of those. If 2D plus 3M is 2D plus 3M. That doesn't go together to make 5DM or something like that. But yes, in essence, as you just saw from the illustration with 2, 3, and 4, these would be the same thing. So by the associative property, yes, these are the same. Okay, let's take a look at 5, 6, 7, and 8. We're going to specifically look at question number 5. It's asking me to find a counterexample to disprove the conjecture. So they're looking for me to show one way it doesn't work, and then it means it wouldn't be true all around because we found the one that doesn't work. And it says in number 5 that a rational number is always an integer. Well, let's take a look at what we've got here. We've got the word rational. What does rational mean? Rational is anything you can write as a fraction. So here we're talking about fractions, really. And then you've got the word integer at the end. And remember, integer is something that shows up on a number line. Sometimes we define them as the counting numbers, their opposites in 0, if that's better for you. So that's your 1, 2, 3, 4, 5, 6, 7, and 0, and then on back the other way on the number line towards left, -1, -2, -3, -4, -5. So all I have to do is give you a fraction that wouldn't fall in that set. Well, that's real easy. If I gave you 3/4, 3/4 is rational because I can write it as a fraction. It is a fraction, all right? But that would not be on the number line. We know the number line 1, 2, 3, 4, 5, 6, 7. 3/4 isn't going to fit into that mix. So there we have a counterexample that disproves the conjecture. 3/4 is a rational number, but it is not necessarily an integer.